In this video, we will be doing Form 4 Chapter 5, Chemical Bonds. There are these 8 common questions that we'll be going through today. So the first common question they can ask you in this chapter is, what is the type of bond or the type of compound? When you see this question, type of bond or type of compound, then your answer will only be these two. Which two? Ionic or covalent. So if they are asking for bond, your answer will be, it will be ionic bond. Okay, if they are asking compound, your answer will be ionic compound. Covalent bond, covalent compound. What is ionic and covalent compound actually? Ionic compound is actually formed from a combination of metal and non-metal. How do I know that whether the substance given is a metal or non-metal? So it comes to the second question now. How I know whether a substance is metal or non-metal? So a metal comes from the group 1, 2, and 13. Group 1, 2, and 13 are metal. So after the periodic table, I think you should be able to tell this, okay, through the period tree, no mother allowed will be metal. So group 1, 2, 13. Non-metal, it comes from group 15, 16, and 17. So there might be some students who want to ask, then how do I know that whether the substance is from which group? How I know that it is in group 1, 2, or 13? How do I know that that element is come from which group? Then it leads you to the next question. How I know that the element whether it's in which group? So you see the question they are linked together. Metal, how I know metal? Group 1, 2, 13. How I know that whether they are group 1, 2, 13? We check the valence electron. So group 1, 1 valence electron, group 2, 2 valence, group 13, 3 valence electron. So we use valence electron. So it will be the same for the non-metal. How I know where does the non-metal comes from? 15, 16, 17. How I know whether a substance given is from group 15, 16, or 17 or not? Valence electron, 5, 6, 7. Okay, can? For the covalent compound, ionic was metal and non-metal. Then how about a covalent? Covalent is formed between non-metal and non-metal. How I know whether an element is a metal or non-metal? The group. For covalent, there's one additional group compared to the one just now. Just now was just 15, 16, 17. Now we have 14, one more group. 15, 16, and 17. I will explain it to you later why there's one more group in the covalent. Why there's one more group for the non-metal here. But the non-metal just now only got 3. Same, how do I know that the element is from group 14, 15, 16, or 17? Which group? We can determine the groups by using the number of valence electron. So 4, 5, 6, 7. So from here, you should be able to understand already the difference between ionic and covalent. Ionic, metal and non-metal. Covalent, non-metal and non-metal. How to determine metal or non-metal? Use the group. 1, 2, 13, metal. The rest, 15, 16, 17, non-metal. But covalent got one more extra group, 14, 15, 16, 17. Next. How does all these elements they combine? How does elements that comes from different groups they combine together? For this metal, they donate electron because they got 1, 2, 3 extra valence electrons. So they will donate this extra valence electron away to the non-metal who is going to receive. You see, 5. In order to become stable, it needs 3 more. So the 3 extra valence electrons can be donated to 5, 2, to 6, and then 1 to 7. So donate and receive. This is how ionic bond is formed. Donate and receive can be called as transfer of electron. Okay, so ionic bond is formed by transferring electron from a metal to non-metal. Covalent compound, how does it form? Covalent compound is formed by sharing electron. Okay, so now I'm going to explain why there's one more extra group for the non-metal in covalent compound. Because 14, you see, let's just say electron arrangement 2.4. How does a 2.4 become stable? Plus 4? Minus 4? Same one. So you see, they don't plus 4 or they don't minus 4. That means they don't donate or receive, but they share. So this is why the 4 valence electron which is stuck in the middle will be used in sharing electron. Understand? So this is the first common question, whether the compound or the bond is ionic or covalent. How to determine? Metal, non-metal. How to determine metal, non-metal? Group. How to determine group? Valence electron. Just like that. Second common question. What is the purpose of bonding? Why does the element they want to form bonds between each other? Very easy. The reason is to achieve stable duplet or octet electron arrangement. So it is like you finding a husband or wife because you want to have a stable life with with another one, with a partner, a life partner. You want to find a life partner to have a stable life. Next, the third common question. Why group 18 is always being left out? The meaning of left out is why it doesn't involve in the bonding just now. We did mention group 1, 2, 13, 14, 15, 16, and 17, but we never mentioned about group 18. Why? Because it has already. So the difference is just now, purpose is to achieve. We form bond because you want to achieve. Group 18 is being left out is because it has already achieved a stable duplet or octet electron arrangement. So that means it doesn't have to form any bond because it is already stable. It doesn't need a partner. So we have done this part. Now the fourth common question. Write the formula of the compound form. Write the formula of compound form. Formula, not equation. So this is what they like to do. They will give you a few unknown and they want you to write out the formula of the compound form. Let's say, again, compound. When you see the word compound, means it can be ionic or covalent. So now let's say I want to form ionic compound from the 3 examples given here. Ionic compound, so ask yourself, ionic compound is formed from metal and non-metal. How I know whether which one is metal and non-metal? We use the group. How to know the group? Valence electron. So here 281, 2.4, 2.6. So ionic will be formed between A 281 and then C non-metal 2.6. How to get the formula? We go back to the question, how to get the formula? After you got the electron arrangement, what you got to do next is just ask yourself this question. How can these 2 atoms become stable? 281, as we said, metal donate, so donate 1, the extra valence electron donate. 2.6 needs to receive 2 electrons. If you can do these steps, you can just cross the number 2, 1. So it becomes A2C. So A2C will be the answer. So the formula of the ionic compound that can be formed from these three examples is A2C. Because we need exactly two atom A. You see, this atom A only got one extra electron to be donated to C. C needs two electrons. That means it's not enough. So we need another A to donate one more electron. So you see, in total, we need two A and one C. Same thing again. Formula of another compound, covalent form between non-metal and non-metal. So you can see 2.4 and 2.6. Non-metal, non-metal. Same thing, ask yourself this question, how can they become stable? So 2.4 needs 4 more. So why do I write a plus here? Because although just now I said that 4 is in the middle, they don't plus or minus, they share electron. Why do I still put a plus here? The reason is because when they share electron, it is like you and your friend, you both want to share money to buy an expensive present for your friend. So let's say the present is 100 ringgit and both of you share 50 ringgit. So when you share the money, it actually plus up together, it totals up together to become a larger amount. So that's why I put a plus. 2.6 needs 2 more, plus 2. Same thing, cross the number, 2, 4. Simplify 1, 2. So it will be BC2. So remember, this is how you solve this common question for formula. We use this crossing method. Element, electron arrangement, how to become stable, and you cross. So use the crossing method to find the formula. Please remember this. So this is question type number 4. Proceed. Question type number 5. Drawing the electron arrangement of the compound form. Now we are going to draw the two compound form, A2C and BC2. How to draw an ionic compound. So remember, ionic means ion. Ion should come with charge. A2C, total of 3 ion. Drawing ionic compound, we need to use bracket. A2C. So A was 2.8.1, right? You don't have to write this. I just want to show you the electron arrangement before they become stable. Before it donates the 1 valence electron, it is 281. So after the electron has been donated, it will be just 28. So first, this is what I will do. A2C. It will be arranged this way. ACA. A donated the 1 electron, so it will be 28. How to draw? First, you draw a nucleus, and then follows by 2 shell, 28. So 1, 2. Okay. Don't know how to draw this one. So 2, 8. This one everybody can draw. But people will always forget to draw the bracket. Bracket and then with a charge here. As we said, ion must have charge. Donated 1 electron, so it will be positive. So A positive. C was 2.6. It received 2 electrons. So it should be 2 negative. So this A is A plus again. So can you see the way of how we arrange them is positive, negative, positive. So they will be attracted to each other. Remember, you cannot draw AAC because the same charge they are going to repel. So what if the compound is made up of 1 positive and 2 negative? Then you put it to another side. Negative, positive, negative. As long as the charge they are opposite, to each other. Then they will be attracted together. So just like that. So remember, this one you should draw 2, 8. This one draw 2, 8 as well. So this is how you draw ionic compound. Remember, bracket and charge. As for covalent compound, BC2. BC2, sharing electrons means they are going to overlap. They're going to overlap. So BC2, same thing. 1B, 2C. What I would do is, how I start to draw this covalent compound is I start from the outermost shell. Draw the last shell first. It will be much more easier for you to draw it. BC2. So let's start from B. How I know that how many electrons should be placed at this part, this area where they share electron. So I go back to my atom B. It needs 4 electrons. So needs 4 electrons means it is going to contribute. If I need 4, I will take out 4 to share. It is like I want to buy a few pencils, but pencil always come in a box of 10. I just want 4, so I share with my friend. If I need 4 pencils, I will pay the price of the 4 pencils. So if I need 4 electrons, I got to contribute 4. So contribute 4 electrons. There are 2 sides which I need to contribute my electron. So each side is going to get 2. So 1, 2, 1, 2. And then next, for atom C needs 2 electrons. So each of the atom C will contribute 2. So let me use a different color. So C needs 2, so it contributes 2. 2. Okay, so this is how you fill up the part where they share electron. Then now how do you complete the structure? Very easy. 2.4, right? So 2.4 after becoming stable should be 2.8. So this one C was 2.6. Become stable should be 2.8 as well. So you see, this is what I do. If I want to complete this structure, so let's say you ignore this part, you just look at this atom C. So the outermost shell now already has 1, 2, 3, 4 electrons. So I still need 1, 2, 3, 4. So I got the 8 already. So I still need 1 more shell for the 2 electrons. So now you can see there is 1, 2, 3, 4, 5, 6. Not 1, 2, 3, 4, 5, 6 again. It's like 1, 2. So 2 done. And then 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8. Done. So for B, same thing you do. You ignore everything. At the side, you just focus on this atom B. Atom B now already has 8 valence electrons. That means it still needs 1 more shell for the 2. So 2, just like that. 2, 8. 1, 2. So 2 done. 1, 2, 3, 4, 5, 6, 7, 8. 8. So this is how you draw a covalent compound, just like that. Okay, so the most important part is where they contribute electron. This is what most people, they don't know how to do. Contribute electron is the same as how many electron they want to receive. If you want to receive 2, contribute 2. Want to receive 4, contribute 4. So this is common question 5. 3 more. Number 6. Compare the melting and boiling point of the compounds, of the both compounds, ionic and covalent. So melting and boiling point, again, is one of the physical property. Physical property. Melting and boiling point of ionic and covalent. So you're going to ask yourself this question. Ionic and covalent, which one has a higher melting and boiling point? The ionic has higher or covalent has higher melting and boiling point? Actually, it's quite easy. I always remember that ionic has metal. Metal always comes with higher melting and boiling point. So therefore, ionic compound has high melting and boiling point, while the covalent has low melting and boiling point. Next, why is it high melting and boiling point for the ionic? Of course, you don't write off because it has metal. That is just a way, a shortcut for you to determine high or low. Explanation, as I said, melting and boiling point in chapter 4, what I mentioned before. Melting and boiling point, we must include force of attraction and heat energy to overcome. Force of attraction for melting and boiling point, we must mention the name. So what is the name of force used in ionic compound? It is the electrostatic. So the compounds or ions, so you can write compound. Usually we write ions. So ions are attracted together by strong electrostatic force. So the force is called electrostatic. Electrostatic force, what is electrostatic force? Electrostatic force is actually just a force of attraction between a positive and negative ion. We always know that positive attract to negative. Why? Because in between them, there is a kind of force called electrostatic. So this is electrostatic. Because it is strong, so we need more heat energy to overcome the stronger force. Covalent, low melting and boiling point, same. Mention the force of attraction. What is the type of force? Your favorite? The van der Waals force. If you don't want to write van der Waals force, you can change it to intermolecular force. Because the intermolecular force or van der Waals force is weak, so we need less heat energy to overcome it. So almost the same as your chapter 4. Only one new thing here, that is the electrostatic force. Okay, so this is common question number 6. Common question number 7. Compare the electrical conductivity of the compound. Electrical conductivity. That means whether they can conduct electricity or not. So same, this is one of the physical property as well. Ionic and covalent, again, which one can conduct, which one cannot conduct? Ionic has metal. So must be the one that can conduct electricity. So you see, it can conduct electricity, but remember to write in the molten state or aqueous solution. What is molten state? What is molten? Molten actually means melted. So that means it is being changed to liquid form by heating until it melts. Aqueous solution is you add water to dissolve it. Example is like, I want Milo powder to become liquid form. I can either add water to dissolve it, which I call it as aqueous solution, or I can also heat the Milo powder until it melts. So we call it as molten. So the similarity here is they are both liquid state. Why ionic compound can conduct electricity in liquid state? Because they are free moving ion to carry electrical charges. So please remember a new thing. When we explain melting and boiling point, we always remember to put force of attraction, heat energy to overcome. Now, remember one more explanation. If it is electrical conductivity, every time when it is about electrical conductivity, we explain free moving ion. It can conduct, that means it has free moving ion. Cannot conduct means don't have free moving ion. The explanation is very easy. So you see covalent made of non-metal. Non-metal, they do not conduct electricity in all states. Do not conduct electricity at all. Why? Because they are made up of neutral molecule. Neutral molecule, which means they does not contain any free moving ion. They doesn't have any free moving ion. So that's why they do not conduct electricity at all. So you see, free moving ion, they are neutral molecule without free moving ion. So cannot. So in the on the ionic side, there is a word but here. It can conduct electricity in molten or aqueous solution, but ionic compound do not conduct electricity in solid state. Why? It can conduct electricity in liquid, but why not a solid? The reason is because in a solid state, ions are attracted together in a fixed position and they are not able to move freely. Not able to move freely means does not have free moving ion. Why? What is the meaning of fixed position? According to what we draw just now, all the electron arrangement that we draw, we see that it must be oppositely charged ion pair up together. It's like positive, negative, positive, negative, and then positive, negative, positive, negative, positive. So all these ions, they are all attracted together in a fixed position like this. They are not able to move unless they are being turned into liquid. Okay, you see, this is like how a solid particles arrange. When it turns into liquid, they will be able to move freely. Okay, they can move freely. So whenever there's free moving ion in liquid state, they can conduct electricity. That's all. And last common question. Compare the solubility of the compound. This is very easy. Ionic compound is soluble in water, but insoluble in organic solvent. Okay, covalent is the opposite, which it is soluble in organic solvent, but soluble in organic solvent, but insoluble in water. So it is opposite. Just like that. So these are the 8 types of common questions that we have go through for today. If you want to copy, then I think you should go back and you just play back and then you stop at wherever question you want and then you copy it out or you screenshot it also can. These are all the questions that I am going to ask you all next week. So please be prepared, especially comparing the 2 physical properties, electrical conductivity and melting boiling point. So that's all for this chapter 5 video. And then for those who want the answer, for chapter 4, now I will be giving you all the answer. Starts from the group 17. You can go to page 13, which we already done it. So this is page 13. If you want, you can pause and screenshot it. Okay, next. Page 14. Page 16, page 17, Page 18. Page 19. Page 20. Period 3. Page 22. Which we have done it in the class. Page 23. We have done the top part. So I think we need the bottom one. 23. Page 24. Page 25. 26. 27. Page 29. Page 30, 30, which we have done it. Page 31. $32. 33. That's all. Bye bye.